Pomeranz-Fritsch synthesis is an important cyclization reaction which has been traditionally used for synthesis of isoquinoline. Basically, the reaction is catalyzed by acid. In which benzaldehyde react with dialkoxyethylamine for formation of isoquinoline. Basically, benzaldehyde react with, here we have benzaldehyde which react with dialkoxyethylamine, where R can be any alkyl group. It is dialkoxyethylamine. It reacts in the presence of acidic medium for formation of isoquinoline. As far as the mechanism for this reaction is concerned, it's quite simple. Involving few simple steps. As the reaction is catalyzed by acids, so it is basically a sort of condensation reaction in which two larger molecules combine after release of a small molecule such as water for give rise to formation of isoquinoline. So this is a sort of condensation reaction. It should be kept in mind that whenever aldehyde or ketones react with amine, it proceeds through a condensation reaction for give rise to formation of amines. So when benzaldehyde reacts with the dialkoxyethylamine, a sort of condensation reaction takes place between these carbonyl group and amine group. A release of water molecule takes place. So we get a compound like which is sort of amine functionality. One of the alkoxy group is protonated. The next step involves the removal of protonated alkoxy group. In the form of an alcohol molecule for give rise to formation of a structure. Like this. In the next step, a proton from the adjacent aromatic ring. Here we have a hydrogen atom which is abstracted or lost. So its bonded pair of electrons shift over here, and the double bond shift here to neutralize the positive charge. So here a proton loss takes place. we get a structure like this. We have a nitrogen atom over here. Because this is still an amine functionality, again the alkoxy group is protonated in the next step. For giving an intermediate structure, like this. This proton is lost in the next step, where its bonded pair of electrons shift and it shifts over here for neutralizing or removing the alkoxy group. So ultimately we get isoquinoline by this mechanism. Here we have nitrogen. Here we have double bond, a proton loss takes place, so we get isoquinoline by this reaction. So this is a very important condensation reaction, especially Pomeranz-Fritsch synthesis, which is used for synthesis of isoquinoline. As far as the structure number first is concerned, this is known as benzoaminoacetal. It is type of acetal functionality known as benzyl aminoacetal.